All right, our first question here. We're graphing both parabolas to see where they intersect. So for the first one, we're using negative b over 2a. Okay? Which means that's going to be negative 4 over a 2 times negative 1, and there's a negative in front of that fraction. 3 negatives means my answer is going to be negative. So my x-coordinate of my vertex is going to be negative 2. When I plug that in, negative 2 squared minus 4 times negative 2 minus 6. Negative 2 squared is a 4, and then I apply the negative to the 4. So negative 4 plus 8 minus 6. That leaves me with a negative 2. So my vertex is going to be negative 2, negative 2. My 1 point will be 0, negative 6. And then if I go on the other side, we get negative 4, negative 6. When I go to graph that, negative 2 is right here. 0, negative 6. 4, negative 6. Now, when it's equalities, we're looking for a point of intersection. It might not be a bad idea to find some of the other points on your vertex. So if I were to plug negative 1 in for x, negative 1 squared is 1, and it's a negative 1. Negative 4 times negative 1 is 4. So negative 1 and 4 is 3. 3 minus 6 is a negative 3. So negative 1, negative 3, negative 3, negative 3 is another point on my parabola. It's good to get some of those extra points in there. Now the bottom one, same deal. Negative b over 2a. Well, that's 6 over 2 times 1, and we put the negative in front. That means my x-coordinate is a negative 3. Negative 3 squared plus 6 times negative 3 plus 2. That's going to be 9 minus 18, negative 9, plus 2 is negative 7. So my vertex for this one is going to be negative 3, negative 7. I'm going to have a point at 0, 2, and I'm going to have a point at negative 6, 2. So negative 3, negative 7, 1, 2, 3, 4, 5, 6. Here we go. We do have a point at 0, 2, and I have a point at 1, 2, 3, 4, 5, negative 6, 2. I'm going to look for where there might be some obvious points of intersection. Okay? Because there will be some obvious points of intersection. Whoops. My bad. Let me put that up correctly. 0, 2, 1, 2, 3, 4, 5, 6, negative 6, 2. Excuse me. Okay? If I start looking at this parabola, I would argue this point right here is probably a point of intersection. This point at negative 4, negative 6. Okay? If I plug negative 4 into the bottom one, negative 4 squared is 16. 6 times negative 4 is negative 24. 16 to negative 24 is negative 8. Plus 2 is negative 6. Negative 4, negative 6 is a point of intersection. Another one that looks like a possibility is negative 1, negative 3. I plug negative 1 in here. Negative 1 squared is 1. 6 times negative 1 is negative 6. 1 and negative 6, negative 5, plus 2 is negative 3. These are my points of intersection. And from there, you want to graph your parabolas. And you're going to point out your points of intersection. Negative 4, negative 6. Negative 1, negative 3. And that's going to be your answer. We're going to graph the parabola. that's going to be x squared minus 4x minus 2. Once again, negative b over 2a. Negative 4 over 2 times 1. That gives me a positive 2 for my vertex, for the x coordinate. 2 squared minus 4 times 2 minus 2. That's 4 minus 8 minus 2. That's negative 6. So my vertex here is going to be 2, negative 6. My points 0, negative 2, and 4, negative 2 because it's symmetric. So 2, negative 6. 2, 1, 2, 3, 4, 5, 6. 0, negative 2, I'm here. 4, negative 2, I'm here. Now, when I go to graph my line, my slope is negative 1, and my y-intercept is 2. Here's the y-intercept of 2. My slope of negative 1, up 1, left 1, up 1, left 1, up 1, left 1, down 1, right 1, down 1, right 1, down 1, right 1. There we go. There's a point right there that's intersecting. Now, here's my parabola. It hasn't intersected yet. Probably have to move it a little farther up. If I were to plug in negative 1 in here, negative 1 squared is 1. Negative 4 times negative 1 is 4. 1 and 4 is 5. 5 minus 2 is 3. So negative 1, negative 3 is a point. And 5, 3 is a point. And there's my second point of intersection. By graphing the points, you should get an idea where it is, and then you try and be a little more specific. So this parabola is there. And this straight line is here. And I would argue that's a point of intersection, that is a point of intersection. So my answers are going to be negative 1, 3, and 4, negative 2. And you can plug them into both equations and they should work for both of them. That's how you can verify your answer is correct. With a circle, your center point's at 0, 0. My radius is 2 because x minus h squared plus y minus k squared equals r squared. So this number right here represents the radius squared. If r squared equals 4, that means the radius is 2. If my center's at 0, 0, I go up 2, I go left 2, I go down 2, and I go right 2. And I do my best drawing my circle. My slope here is negative 1, and my y-intercept is 2. Put it in a different color. My slope is negative 1, and my y-intercept is 2. So there's one point of intersection. My slope being negative means I go up 1, left 1, up 1, left 1, down 1, right 1, down 1, right 1, down 1, right 1. Once again, the points of intersection here and here are your answers. 0, 2, and 2, 0 is your answer. I will also ask you to do this algebraic. So the algebraic way is this. We use substitution. We substitute 2 minus x in for y, because y equals 2 minus x. You have to FOIL the 2 minus x. It's 2 minus x times 2 minus x. So that becomes plus 4 minus 4x plus x squared equals 4. When I combine and move everything over, x squared and x squared is 2x squared. We subtract the 4 on both sides, the 4's go. Minus 4x equals 0. And now it's basic factoring. Take the 2x, and 2x minus 2 equals 0. So 2x equals 0, x minus 2 equals 0. Therefore, x equals 0, and x equals 2. When x equals 0, 2 minus 0 is 2, my y equals 2. When x equals 2, 2 minus 2 is 0, so therefore my y equals 0. And these are your two answers. Previous problems you had to solve by graphing. I will be very specific. I'm not going to make you do both. The graphing problems, these are the substitution problems. I'm not going to do the elimination method in here. So y equals 2x minus 4 means I can put 2x minus 4 in for y. And anytime we have a problem that has an x and an x squared, we want to get everything equal to 0, with the x squared being positive. Since my x squared is already positive, I'm going to subtract 2x on both sides, and I'm going to add 4 to both sides. So this ends up being 0 over here, and we get 3x squared plus 6x minus 9. And my advice here is this. You're factoring as you've always factored. You take a 3 out, and you're left with x squared plus 2x minus 3. And then when you factor it, x squared, you use x and x. The factors of 3 that can get you to a positive 2 are plus 3 and minus 1. So x plus 3 equals 0. X minus 1 equals 0. X equals a negative 3, and x equals 1. And now you have to plug both x's back into an original. It does not matter which original you choose. I'll choose the easier one. 2 times negative 3 is negative 6, minus 4 is a negative 10. That's one answer, and you do have to match the correct x with the correct y. 2 times 1 is 2, minus 4 is a negative 2. So the other answer is 1 equals x, and y equals negative 2.